Alright, in this video we're going to talk about reference angles. Alright, what is a reference angle? So it's the angle formed between the terminal side of an angle and the x-axis. Okay? It's good to remember that it's always non-negative and never more than 90 degrees. So it could be any measure between 0 and 90 degrees inclusive, or 0 and pi over 2 radians inclusive. The symbol that we use for reference angles is this cool symbol called theta hat. I didn't make that up. It's actually called theta hat because it looks like it has a hat, or sometimes it can be drawn with a little apostrophe. So if theta is an angle, then the theta hat is the reference angle of that angle. So let's look at how we can express reference angles when the angle terminates in different quadrants. Alright, now for quadrant 1, the reference angle is equal to the angle. So quadrant 1, so theta hat is equal to theta. So what does that mean? If this is theta, and that's assuming theta is between 0 and 360, so let's say that this was a 65-degree angle. Alright, well then theta hat is also going to be a 65-degree angle because that's how many degrees it is to go from the terminal side to the x-axis. Okay, now for quadrant 2, if theta is in between 0 and 360, alright, the way we could find the reference angle is to take 180 degrees, okay, so theta hat, the reference angle, is equal to 180 degrees. And then this here, I'll write it in blue, represents theta. Okay? So this part right here represents theta. So if we subtract theta from 180, look what's left, just that orange part right here. Alright, that's the reference angle. So when theta is in quadrant 2, the reference angle is 180 minus theta. Okay, in quadrant 3, it's a similar idea. Alright, so if theta belongs to quadrant 3, and, oops, that looks like a Q. Let's make it a theta. If theta is, now it looks like a Ninja Turtle, but whatever. If theta is in quadrant 3, and theta is in between 0 and 360, alright, I put an extra thing down here, I should get rid of that. But anyway, theta hat is going to equal the angle itself, alright, so this in purple represents the angle, and then subtract 180. So you subtract this 180 degrees, and you're left with the reference angle, which is right here. Okay, if theta is in quadrant 4, so the angle terminates in quadrant 4, and it's between 0 and 360, the reference angle here, we can express it now as 360 degrees, which is this full circle, and then minus theta, minus the angle. So subtract all this part right here, right, and we're left with just that part right there. So that's how you find a reference angle for an angle in quadrant 4. You subtract it from 360, assuming it's in between 0 and 360. And for any of these, if you have an angle that's not in between 0 and 360, you could just use a coterminal angle that is in between 360 degrees. So what do I mean is, like, find the reference angle for, say, like 550 degrees. Alright, well, first I'd find a coterminal angle, so that's going to be 190 degrees. So that means if I were to draw this, it would look something like that. Alright, so the reference angle would be 10 degrees because it terminates in quadrant 3. So if I did 190 minus 180, I would get 10 degrees. Alright, so we got 190 minus 180, you're left with just that part right there, 10 degrees. Okay, so let's practice finding the reference angle 2 other times. Alright, so you could use the method where I just showed you, where you find an angle coterminal to the angle in between 0 and 360, alright, and then use one of those formulas. Or you could just kind of draw it out and think, how many more degrees to get to the x-axis? So if I was drawing negative 147 degrees, alright, this would be the initial side right here, and then I would go 90 degrees this way, and then 57 more degrees like that. Alright, so this would be 90 degrees, this would be 57 degrees. The reference angle is always formed with the x-axis. Alright, so it's going to be this angle right here, which the complement to 57 would be 33 degrees. Alright, so theta hat in this case is going to be 33 degrees, because that's how many more degrees you need to go to the x-axis if you went 147 degrees clockwise. Alright, for this third example here, 11 pi over 3, well, it helps to put everything in degrees first, because that's what you're probably most familiar with. So if we multiply by 180 over pi, we get 11 times 180 over 3. Alright, if I'm doing this without a calculator, I like to do the division first. So I get 11 times 60, and I get 660 degrees. Okay, so you can now find a coterminal angle, or just kind of draw it out. So you go 360, and then to get to 660, we're going to go 300 more. Okay, so that's what the angle would look like. Okay, so that means if we went 360 plus 300, then that means there's 60 degrees more to get back to the x-axis. So our reference angle, alright, so we did minus 360, we had 300. So we're pretty much finding the reference angle for 300, which would be 60 degrees. That would be theta hat. Alright, that's the first part of this video series. I'm sure there'll be a few more.